Okay, good to see you again, and let's continue with the videos while I'll work with the Wusik ZR code. And right now I'm working on the wavetable code. I have copied my filter code that I have from I'm using the filter code from Juice, but I converted in a way that I can use much faster with the sim instructions. But I'm not getting very good results, so I'm going to try to oversample by 32 times and see here how it sounds. For that, let me change my loop in here because it's fixed to 8 and I was using 16. Here's there's something very strange with that. It could be two things, so let me first take a look at the code again and see where it wraps around. Now, if I'm not mistaken, it should be -1 of the loop size of my wavetable. And let me check where I'm creating the wavetable. Where is it? Hey there, just checking a few things out in here. I don't remember where I created my wavetable. Oh, the data structure. Never mind. In here. So it's actually -1. Actually, no. Sorry. 1. And then in the last one, it's 0. So let me try that. Actually, I'm here two problems actually. This pitch change in the start. Not good. It's very strange. I guess we'll have to fix that before anything else. Let's just leave oversample as 2, just to be sure that's not a problem. Actually 1. Okay, definitely not oversample. I have to check my update rate, probably is doing something wrong. Okay, the update rate is doing something strange, so I have to check that. Now, while I do that, I want to try the oversample again. As I was talking before, since we just got in here, I was testing my filter code from the Juice library. And delete this now. Already converted. It's a very simple low pass filter. If you look on Juice DSP, on the benchmarking I have here, Juice DSP filter, ERL filter, no ER filter, I don't know how to pronounce that. I always get confused with that because it's two letters I and the R. Yeah, good one. And I just took the coefficients from the low pass filter and I copied the code directly. So here's the one, make low pass. But this code is very new. The one I'm using is kind of old, but still works very well. So I just added some variables for the coefficient. Where's the wavetable? For the filter buffer, I'm using 3 poles, so I'm processing one filter, then another filter, and then another filter, all in series. So we have 3 pole. I think that's the correct name, 3 pole. Anyway, I'm running the filter 3 times, but with different buffer values, so it's like having 3 different separate filters running in serial, just like that. The filter coefficients I'm writing to 8 values, so I just load the coefficient in one go, which usually is faster. And then I just process on my voice processing. Where is it now? Oh, here. Process voice and then the oversample voice. I'm going to try. Let's try to oversample again. Because if I don't get a very good result in here, I will have to do 4-point sample. Not getting any better. So I have to check what's going on now. Sounds very strange because if I use the drawable oscillator from Wusik station, let's say it's loading there, load P2000. I have my keyboard. Wusik station 9. Okay. Replace. replace. What I'm doing? Replace with draw wave oscillator. This guy here. Okay, now let's turn the high quality mode. Let me check if I'm not oversample by 4 times. Okay. Very clean. Disable high quality and oversample by 16 times. Spot on! So I'm pretty sure I'm doing something wrong. Can I just delete this? Ah, crap. Let me close this so I don't get strange values. Because the filter seems to be working. I was testing if I lower the sample frequency, frequency to 2000, does muffle the sound. But let me check on my draw wave oscillator how I'm doing the interpolation. Maybe I'm doing 4-point sample interpolation, which is much better. And I'm pretty sure I'm doing that. Now, where is it? Let me check something. Morphing, not morphing. I have no idea. I never tested that before. But the filter code I'm using is very simple, so should run pretty fast. Anyway, I'm looking at my draw wave oscillator just to check how I did it. And it seems that I'm using 4 samples, 4 points Hermit interpolation. And I'm pretty sure about that. Let me double check. Where's this samples? Weird. Okay, this is just weird. Where is this variable? Oh. Okay, now, what the hell? That's just weird. Um, I don't get this. Anyway, I'm getting this now. Let me check my sample player code because there I'm sure that I use for 4-point Hermit interpolation. That's one long name. And I even made the code of the filter already in SSC here. And the code's already in there. And it's 1B code. But before I go too much further with these, think of something. Yes, I could, but then it gets very complicated to understand. But oh, the X compute. That's a mess of a code created for the Hermit manipulation on the sample player. So it's just a definition in here, and this is very messy. But the code I'm using, let me show you where I got the code from. It was a long time ago. BSP. Hey, they changed it. Oh, nice. Here. And I think this code was even created by me, if I'm not mistaken. Not this code, not this one. But there is one I created and posted in here. But the starting point was not this one. Let me find the one that it started with. Yeah, this is the one. And let's see if my post is in there. No, it's not. I did create an SSC code and post it in there. Let me copy this. So I used one of these codes. I think it was the first one, which works really well. because there is one here that uses the minus, and it's a bit hard to use. So it's like one sample before the current sample and two next samples. While this one here, you get the fractional, which is we already have on the wavetable code, is the samples interpolation value. That's the fractional, and then you just have to get the current, the next, and the next samples. So this coding here should work pretty well. But I did create an SSC code for this one and posted it, but maybe it's no longer here, or posted somewhere else. Let me see if I can look for my name in here. Now I can look for my name. But anyway, that's the code. So first, I'm going to convert my mess of code in here, that. And then I'm going to worry about the oversampling. I should have done this before, but I was hoping that it was going to work great with the oversampling alone, but it doesn't. So the first thing I have to do is change my whole code to load 4 samples instead of 2. Processing block transitions. Sorry, I don't understand what you mean about processing block transitions. Explain just a bit more so I understand. I don't know what that is. Okay, so the first thing I have to do now is get 4 samples instead of 2. And for that, I'm going to change my samples value plus 3. And then on my creation process in here, I have to copy the first wave table, so it's going to be 0, but just in case. Okay, the audio comes in blocks. 256 samples, okay. Oh, okay, I see what you're talking about. The interpolation, well, actually interpolation is done per sample, so you don't have to worry about that. Each sample, you process the interpolation. And then you accumulate in the filter with the oversampling, and that's pretty much it. I don't worry about the next sample or things like that. And with Hermit interpolation, you are actually calculating for 4-point interpolation, which is what I was showing on the graphic, on that graphic on that site before. That's just the way I have been doing, like, forever. So if there's a better way to do it, I really don't know. So I think this should be enough. I just copied the last 3 ones, actually should be. Yeah, that's 3 ones. Just let me put, I know this is irrelevant, but it makes the code looks a bit better. So now I'm setting my data structure for the wave samples, adding 3 samples at the end, which I copy, so I have to remember that. And now let me comment this out, just in case I need to take a look. But what I have to do now is load 4 samples instead of just 2. Well, could reuse a bit portion of this code. Let me elevate this to 4. Samples is 4 now. Because here I'm loading 2 samples. And now let me think, because now I have to shuffle these values around so I get the next 2 samples. I actually already loaded 4 samples in here. There is another call. This is load high, but there is a high load too. So let me check that. I think that's the one I want. I don't know if maybe I didn't understand the question correctly, but thinking about it, I just each process call I calculate for the sample, so I don't really bother about anything else. Okay, here it is. They move high to and low. So it's getting, let me compare this just so I'm sure I'm doing it right. Windows. Come on, man. Left. And let me load this guy up in here again. Low, high, high, low. Yeah, that's exactly what I need. But I have to be careful because it loads in a different way, just to make things more complicated. You can see here the load high low will get me the first 2 from A and the first 2 from B. And now it gets me the first 2 from B and then from A. It's not a big deal, but I have to be careful with that. So I have to invert my values in here. So I have to put those guys in here instead. So 0, 1, 2, 3, 0, 1, 2. I'll put L for last. And move high, low instead of low, high. Low, high. That sounds a bit funny. So now I have double check that. From B, the last 2 from B. No, not like that, my friend. Not wrong. It's wrong. It's actually V1, V0, and V3, and V2. I have to reverse. I don't know, it's making this so complicated. Okay, now that's correct. That's going to get me voice 0 sample 2, 0 sample 3, voice 1 sample 2, voice 1 sample 3. Now when I do the shuffling, I have to do the shuffling in a different way now. Well, actually no. I can do the same way. Okay, now I have 4 voices, 4 samples in here. For the SSC, let me do for the AVX, for 8 voices. Just low, 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 because it's easier. Low, high, low, high. No, it's high, low. Very low, high, now it's high. And reverse all the values. 0, 3, 2, 4, 6, 0, 1, 1, 2, 3, 2, 3. And just put the right name in here. Of course, it's going to run much slower, but at least we don't have to oversample so much to get a good sound. And I was thinking, one idea I was having about, well, let me worry about this last at first, and then I have some other things I want to check on. So okay, we have the 4 samples. Interpolation is not going to be like that anymore. It's going to be like this. Okay, loading 4 samples is not so hard. And I'm just adding actually 2x instructions in here because I was already loading 4 samples before. So this part should not add too much to the code actually. Check what I did wrong in here. Oh yes, of course. Let me remove this for now. So let's do this code now. Which can be a bit of a pain to do, but it'll be okay. So we call create samples. This is about the samples 1. Check if it's loading correctly. Yes. But I like to use this better. I just prefer that way. So let me put this in here. Equals. So one thing I always get confused. What happens first? multiplication or addition? I always get that confused, you know. I don't know why, but order of operations, Wikipedia. Ah, nice. Internet is your friend when your brain doesn't work. Okay, so multiplication always comes first. I was going to say that, but who knows? So let me put this more clearly for me to see before I make a mistake. Like this. Ugly. I think it should be like this. So let's go with that. C1 equals 5 times samples 2 minus samples E. Let me copy this. And I can actually go like this. Sure. This is the boring part. Zero minus 3.5 minus samples 1 samples 2 samples 3. Samples 1 samples 2 divided by 1.5 plus 3.005 times samples 3 minus samples 0. Then I have to double check just in case. T out. Now we go like interpolation. C3 times sample interpolation plus 2 times sample interpolation. C1 times sample interpolation plus C0. Not bad. That's a long thing. And I can just go like this and just write the output already. voice output. And I forgot to close something. That always happens. Oops. Samples. Okay, let me double check the whole thing up. So C0 equals the first sample, then is the second, actually first not the second sample, but let's say first sample, sample 1, and sample 2 and sample 0, 0, 1, 2, and 3, then 1 minus 2, and 3 minus 0, and then we just process the whole thing up. 3, 2, 1, 0, and copy to the output. Okay, so already sounds better even without interpolation. So tx input. No need to put equal. Let me try the interpolation just to see how that works out. Input that, and out is right on the last part. That's another sample by 8. Then I have to optimize that because always not going to be optimized at all. I'm pretty sure I can optimize this code. Forgot to remove the low pass filter from 2200 to 22,000. Jude Strange. Maybe I'm overlooking something again. I hope not. Not right. Let me see the filter inputs in there. This is the 4-point sample interpolation. I think I see a problem in here. No, that's correct. is so weird. Like it's not over something at all. I know what it is. I made a small mistake. Oh, bloody hell. Okay. There is a problem here. Voice envelope. Process the voice and mix the voice. E. There is the problem. There is no oversampling in the processed voice, and it should be working like this. So it has to be in a different way. I'm going to call processed voices, and I have to do this in a much different way. But now at least I have two codes that I can test. I'm going to leave all this simple linear processing code there. Going to be process voices SSC, the voice block. So it has to be like easy step. It's going to make sense in a minute. Just give me some time. This mixed voice no longer be used. Let me do the SSC first. So here I have to do the oversampling loop, because I'm not getting the other values for the other samples. And then and compute the oversample voice in there. So I load the samples, and now I process the voice. I can try with just 8. If it compiles. Much better. But it still sounds a bit off tune. I don't know why. I have to check what's doing that. Yeah, there's something wrong in here. But I will figure something out. But the resulting sound is much better. Let's see, oversample by 16. So the filter is working, the Hermit interpolation is working, hard point interpolation. Baby. Just have to check why it's drifting the audio like that. So let me check that now. It's on the update rate. So have this sample oversample cycles per second. Find cycles. Double varying here. I'm not sure if that's a problem, but who knows. And I have the pitch bend cycles. But for now, I'm going to remove those two guys and try to figure out where I did something wrong. But it sounds like crap. The tuning, the pitch actually. This should be double as well. Maybe, let's see, one thing first. Almost perfect. It's actually very good. So let's try to figure out the fine tuning here. We will find of the voice, tone refine. Check if I'm actually resetting this value, maybe or not. Oh, 0.5. That's correct. Maybe the pitch bend. I forgot to initialize. Yeah, it's only fine. But why is it doing like that? Okay, fine tuning received from the owner. But no, that doesn't look bad. Cycles equal 0. Negative, this should be 0 too. So I don't know. Where's the fine tuning? Okay, the owner fine tuning is the one to blame. Where is the fine tuning? Hard process. Operate and fine tuning. Pitch bend back. Weird. Why is it doing like that? That's so weird. There must be something I'm overlooking. So the fine tune is a pointer. Okay. And the process, I just set that from a value list of floats. Weird. So it's crapping up like that. Like my value list is getting recycled, but it shouldn't be doing that. Strange. I'm going to use a real value instead of a pointer. But it do not require that. Start process, float fine. Let's complain. Pivot table, start process. Change it. Okay, let's go here and change that and see what happens now. Why it's doing that? It's so weird. Okay, that's just very weird. What's going on? Ah, really? You did add an LFO in there. Okay, I added an LFO to the bloody thing. That's why I'm doing that. Let's sure improve the code a bit in here, just in case. Okay, one thing I just remember why it's acting like this. My sound card. Perfect. New device. Wave output. Dishes. I was thinking it was that, but seems not to be like that. Anyway, I have to check my rate counter in here and make it happen faster. Check my wave device again. Direct sounds would be better. Buffer. Buffer. 56, 256. It doesn't even work. Device, output device. I don't know. Speakers view tech. Okay. Weird. Reaper's audio system is a bit crap if you ask me. Well, anyway, it's working now. Now I can test if I really need for samples in just instead of Hermit interpolation versus linear interpolation. And then we can discuss the price of each one in terms of CPU usage. Because I'm oversampled by 16 times and it sounds really good, not perfect, but really good. Let's try 32. Let me fix my audio device first. That sounds fantastic. So now let me load my benchmarking guy. Fix the processing code for the change it. Voices. Now here the process voice. Change that. Okay, that's good. Let me remove my envelope tests because I don't know use those guys. But actually, I don't know if remove. I'll just jump to position. Okay, let's see what that looks like. Let me lower my loop in here. Okay, 6.9. The EVX didn't complete the code, so let's not bother about it now. So 6.92. What I want to know now. So I'm oversampled by 32. But how does it goes with linear interpolation instead? For that, I don't need a second call here. And we just go. I don't need it either. So disable the Hermit interpolation and go with linear interpolation instead. I'm going to compare and then compare the sound. Okay, 4.9 seconds. But now I have to check how it sounds. My eyes paging again. Because the lamp I'm using here very strong, so it gets on my eye. I would say that this sounds very good actually. And it's much faster to process. Okay, I'm going into a very high frequency here. And let me check something or anything else. My samples as before. Let me try again with Hermit. Maybe I should create I'm going to create some proper benchmarking for the sound so I can really test. And for that, I'm going to create a small sequencing here. And how do I go about recording? Record Arnet. Recording here. There you go. Hey, where did you go? Oh, come on. That's just dumb. Where is it? Okay, save all. Isso. So now I want to export this. I never used Reaper before, so give me a break. I'm used to Sonar instead. Render directory. So this is linear processing. Okay. Now let's put back the Hermit interpolation instead. And now let's load the Reaper again. And render again. Just by the time it took, I already know it's much slower, but it's really not a big deal. Because I'm processing 32 voices. That's why it takes a long time. Okay. Damn it. Well, to be honest, I don't hear much difference. And now, I'm going to leave this code in here just for a while as I work on updating everything else, but I don't think there's much advantage on it. Seems to be performing very well for 32 times oversampling. And there's one thing I was thinking about is the contrary to interpolation when it's moving very fast. So it's for when its rate is above 1. No, wait, not that. when the rate is above the sample rate of the waveform. So when it has to go slower, it has to do the opposite of interpolation. I was thinking there are a few ways to do that. Let me first fix the code in here for the processing. Voice sample. Just fixing the AVX code so it runs correctly. I was wondering if there is a way to tell the compiler to unroll a loop. You can run a bit faster, but takes more memory. But I know there's some stuff that you can do on Visual Studio, but I never really found anything. I did look, but I just didn't find. Okay, so this is my numbers that I want to take a look now and see if I can do something about it. So let's think for a minute in here. Close this guy for now. Avoiding problems. Okay, we have a wavetable now. Kind of working. For me, it's 32 times over sample. It is a lot. Let me check my processing, the performance of that. It's hard to tell because I have so many processors. And it's already taking into account what am I going to do about that. Benchmark could do that for me. With a benchmark, let's say, oops, 4,500 samples. One second equals 100% of the CPU. So for the wavetable SSC, 22%. That's kind of heavy if you think about it. I'm going to go with these values in here and see if I can improve the code a bit. One thing I want to test if what's the minimum. Go to the Wusik ZR code and see what's the minimum I can get of oversampling before it starts to sound very bad. Because of course I can add like 18 is the regular oversampling, and I can add now another option to the plugin, call it high quality. And then instead of 8, I just go with 16, because with 8 the sound is already very clean. High quality. And on. I have to add this my enumerators list. It just after mode. High quality. Mode and high quality. Okay. There's one thing I don't remember about. Yes, I can, but it's been a long time since I have done this. Spectre Analyzer, I think Reaper has one. Let me check, it should be in here, and I add the VST. Use resource, Reaper cast, compare, here. I think it's the fear one, right? If you know which one it is, just please do tell me. Sorry. Don't forget that this is a sawtooth waveform, so let's compare this up. First thing I was going to do, okay, I have added the high quality option. I'm going to maybe add more than one option for the oversampling. I'm just trying to remember something. Just a minute. The value, which is the initial value, and the maximum. Right. Quality. Low, normal, high, higher. Let's try that. So the default is going to be 1, 0, 1, 2, 3. 2 is the maximum. Then you can compare. Then I can put this wavetable. Oversample is going to be a variable instead. Has to be integer. Default is going to be sample 8. in here on my processing. I'm going to put a check. Well, actually, the oversampling can be global. Okay, it's going to be the default until start process gives me a new number. Oh. Instead of quality, just quality. That should give us something to work with. Where's my, oh, here. Oh, I can open that. Oh, I can. Because I want to be able to change the my other screen. So, okay, attack 0. I have to create a project again, I guess. There is just one theme here. Low, low, high. Not draft, it's called. I saw this draft option one time in the SFZ player instead of normal. A bit gimmicky. Let's browse here. Here's my ZR. Ah, what gives your project? That's not good. How can I change it? It's behaving like that. Okay. We're sustaining here. Not so much release. Weird. Weird. Strange, there's something weird. That's no good. Some strange noise get in the way. So let me just double check something. Let's complain about that. One thing I was thinking about process to be released again. That sounds muffled. Check some. It's just weird. Well, anyway, let's try with the PowerPoint sample interpolation and see. Doesn't prove anything. We first take some screenshots of this. Drive the maximum oversample, which should be 32, if I'm not mistaken. Print screen. Okay. Well, let's drive something a bit lower. Normal, high, normal. Print screen again. Not correct. The wrong key. Oh, okay. The difference is there. Let me show you. Does get this is with normal quality. Looks like the filter is doing something wrong. Okay, let me test now with the Hermit interpolation. And thanks for the idea of testing with the visual analyzer, digital spectrum, whatever. Eyes are better than ears. Sure. Print screen, not pause. Oh, here, switch. Okay, Hermit interpolation is doing crap. Almost nothing. At least for this node. So, really not much use for that. I just don't get why. Get why on low values the filter is acting more. It is acting a lot more. So I have to check what's going on in there. Adjust the filter maybe because something strange is happening. Let me check my coefficients if I didn't do anything wrong, but they seem to be correct. Maybe we could adjust this a bit depending on the sample rate. Do a manual adjusting. Thanks, man. Something like compensation value. And then manually check for that, depending on the oversample. 2000, I guess. We'll see what I'm up to in a minute. Maybe. Because it's going the opposite way I want. 32 minus. Yeah, that's the problem. It's going to work out eventually. Ugly. Because I'm doing the opposite way. It was 22,000 hertz, but I need to compensate for the oversample because this math is not totally correct. It's a bit off. Because if you hear the filter is going too high. Here. Yeah, the filter is not behaving correctly. So let me check something. Let me check the original filter design. Make low pass. It can't be higher than a sample rate 5/2. That's correct. Okay. This is a very different math because this is a much newer code, so I don't know what they are doing with this. Let me compare with the code I have right now. Oh no, this is something different. Verse 2. Okay. So what I could try is make a small curve over sample minus 8. And start subtracting. Start with 24 times. Now I'm just guessing. Not bad, but I don't like that. But just so the filter behaves more correctly when the separate goes up higher. Oops, I broke something. Over sample minus 8 times 1000 is too much. More like times 200. Oh, monophonic. It's almost like that, but a bit more aggressive. What was the value for? 8. Could just do a mapping, I guess, but that's too much. I will get it. It's going to work. Just a small thing to worry about. Almost good, but I was thinking, I don't remember having this problem with, well, I'm not over something 32 times, so never mind. Two, 48. I'm just guessing the numbers. Sometimes you just have to guess things out. Or just construct a table in something and try to understand what's going on. Nah, it's not fun. Well, almost there. The bottom part, I got it right, just the upper part. No, went too far. Oversample 8, where is my 8 plus when I first started programming, I was do a lot of divisions by zero. Man, it was a pain in the ass to get things right. My bottom value is 8. 8 minus 8 is 0. It's behaving so weird. Maybe my code has some limitations in terms of how many oversamples I can do it. This is just ridiculous. Are 72 then, but that's wrong. I'm just guessing. Weird. Let me just double check this guy. I'm starting to get upset with this. This is not correct. Why it's behaving like that? So let me try to recreate the coefficients again, just in case. Maybe I haven't seen something wrong. So suppose numeric time frequency numerical sample rate. Numeric type is undefined. Ah, fudge. Now they change it. Let's just double pi. Double pi. Sample rate is a float. Q is inverted. Insert. What the hell is that? The problem is that it changes so many things in Juice Lady that sometimes it's hard to understand a new code, because I'm used to one type of thing and a lot of this thing is new to me. The coefficients now is going to be like these. So coefficient 0 equals 1. Coefficient 1 times 2. 2 equals 1. 3 equals 1. Oh, interesting. Coefficient 4. 1. Okay. And finally coefficient 5. Oh, that's no good. I have one extra number now. 0, 1, 2, 3, 4. Bloody thing. Check again. Oh, I have 6 numbers now. Even that they change it. That's not. Hmm. Let me check my numbers. Uh, was looking at it, there's a lot of similarities. Ah, so actually this is like 432 0, kind of like that. Let's double check. Not so much. If I go from bottom to top, it is equal. Inverted Q and the squared. This guy here is not right. Yeah, the code is totally changed, so I don't think I can really use it. Sorry for mumbling. I'm mourning. To try just worry about the last part and reuse what I have already. Already? Yes, to all. I'm just going to test this one out. Okay, let me check what I changed in here. 1 divided by double I. Oh, there's no sample oversampling here. but it's not changing much, to be honest, because it's the same problems before. So maybe I will have to try and use this filter. I don't really remember how to use a filter. It's been a while. I'm going to just make a quick testing here. Let's see if that at least improves the audio. Then if it does, I will try to use it. I don't have a filter in here, I have to add. Close everything and add DSP to the project. Wusik ZR, introducer, module, global, DSP. Filter. One filter per voice. In the reset, I'm going to create a filter. What the hell? They changed everything. That's not good. Order. Free. Oh, come on. I have no idea what type of window. Why people make things so complex? This. Filter design. Gosh. What happened to just a low pass filter? Really gets me on my nerves. Kaiser, I want to know the beer. Frequency, sample rate, normalize, position width. Position width. I have no idea. Oh, unsuccessful. Go here. I'm starting to get upset with this. The second time it get on my nerves. It was so simple before. It has two classes for filtering, processing, and the construction. Now it's all this design crap. Why not make this a new function and leave the other one behind? I don't get this, guys. See, that's not even on the DSP in here, on the old code. So they changed this very recently. I don't remember where is it, where it was. That showed me a lot of stuff. I was using already filters. Crappy thing. Let me check something else. Because I created a filter some time ago that was working. Okay. Let me check what's the status on this one. Let me see if I can find it, because it's a very old code. Old code. It's so simple design, but on the LFO. It's just a single pole filter. Is the design for it. Let me try that one out. Maybe it's not so bad after all. For that, all you need a buffer and a frequency. Just that. And there is the filter design crap. No longer going to use that. Sorry guys, I just get upset when people complicate things and don't leave simple solutions behind. I don't mind complicating. I bet those filters are awesome, but I need something simple. And that's not it. Filter one, full buffer, frequency. So we just have the buffer and the frequency. And as always, zero those guys out. The buffer to clear in the reset area. And we'll compute the frequency here. It's this guy here. Rate. sample rate times sample, which is in double. And now we store the filter frequency. The filter frequency is the same. Actually, we don't need that many voices for the filter frequency, just 8, which is the AVX maximum number of numbers going to load. And we store this guy up. Oops. And this, you actually can oops. And we store for the next 4 numbers too, so it's compatible with AVX. So this is just one order, so I have to test how many I'm going to need. But for now, I'm just going to compute this one up. And the buffer is very simple. The buffer equals the X input minus the filter one buffer filter frequency multiplies frequency plus the buffer. So maybe it's best to store the buffer first, because it's going to be reused many times. The input minus buffer times filter frequency plus the buffer, and we write this back to the buffer. And actually, equals that, and then we write X out the output. Yeah, it should work. It's very straightforward, but it should work. Or not. Complain about zero. This is not outputting. Feliz. Now this one still muffles a bit. Let's try to adjust the frequency now. And this one should also load much faster. 28. I notice the volume is a bit lower too. That can be adjusted, I guess. Okay, not so bad, but there's still a few problems. Let's see if I can compensate this. This is still one hole, so maybe let's try. Yeah. I was thinking about why I'm getting different value in here. Be 0. I have the same problems before in the end, so the only advantage in here is this code runs much faster. Oh, the volume, I found the problem. That's just weird. It's too going too low and too high. I don't get it. Because when it's on regular mode, which is 8 times oversampling, it's still cutting too much of the higher frequencies. Not so much now. Hey dude, just fine. Try to fix something here in the code. Hope you're fine too. I'm a bit upset today because my filter codes are not working the way I want. But I will figure something out. This one is opening way too much. Try to close. I just have to find the perfect spot for it. Right. There's something strange in here. Oversample. Oh, I have no idea. Sorry, dude. But it is a lot. From the last time I checked it, it's a lot of people. Start process over sample. It's 8, so I don't get what. Something very strange happening in my mapping here. So I'm going to do crazy thing here, because this is hard to debug. Not impossible, just hard. If I'm still interested, well, I have 2 projects to finish. This one and another 2 other projects, so I'm already a bit swamped. That's 1 second. Have a second. And text. The test I want to append. And want to know what the hell is going on in here. Sample value. And this guy here. Forgot. So let's see what's going on. I'm going to start. I'm going to run very slow now. Quality is higher. Put quality as draft, which lowers my frequency, which shouldn't be doing. Where's my file? Huh. This is happening. Oh, I put in the reset. Oh, I made a mistake. Come on. Can I cry a bit? I'm doing all my computing in the reset part, and if I'm changing the quality, does it reset? On process, start process. No, it doesn't reset. Yeah, I made that. So, okay. Don't you love when you do this stuff? So my filter design wasn't so crappy at all. My brain is the one to blame. So let's go back. Put everything back again. That's why I say I'm swamped. It's too many things to worry about. But I can do it. This filter I'm not going to use anymore. For the Hermit interpolation for now, I'm going to leave it alone. So I first test everything again the right way this time. Blurry Canolio. All this all was good. No. I have no idea what's the difference. I really don't know. I'm not a very expert DSP designer. I just created some DSP a very long time ago, and I'm reusing stuff as I go because I don't know. I used to have a partner that helped me out with DSP design, but he left. So I'm trying to get on my own, but I don't know that much about DSP. Okay, so the computing of the filter design must happen on the start process. That's why it was not working the way I wanted. So maybe it doesn't need any compensation at all. Just should be able to put 22,000 hertz, and it should work. Oh, since I do it in the start process, I have to declare my coefficients in there too. It's not a problem. But to be honest, I was hoping to reuse this code a bit to do something else later, but maybe not. Let me check something out. To do that in the separate update. Or on the change waveform. The change waveform. So now just go. But for now the frequency is fixed for all voices. But my idea is to lower it depending on the frequency of the node, and that's going to be very good on lower frequencies. So for now I'm just setting this directly, and let me change this per voice already, so it's going to be 0, so it's filter coefficients. Remember the coefficient is 0, and the voice, yeah. 0, 2, oh that's right, 2, 2, 1, 2, 3, 1. I'm saying out loud so I don't get confused. 4, 0, and that's it. Now I'm saving per voice. So each new voice is going to receive that. Maybe I can put this on the update rate actually. Now it sounds much better. So that's 8 times oversampling for the basic waveform. There must be a better way to do what I'm doing here. How do I hold a note on this virtual keyboard? Okay, that should do it. Okay, that's how it stops. Here. Let me do the screenshot again, because now it's bloody working. Okay, it looks to be a bit better. Yes, much better. High quality one, producing much less aliasing. And I want to improve one thing now. As I was saying, maybe I could go on the rate, but maybe there's no real need for that. There's two things in here. Because I want to know the frequency. So let me create another variable here where I can store the frequency. Frequency. Let's see if that's going to work out. In theory it should, but who knows? Zero, actually, zero. Just close the filter, maybe just 100. No, doesn't matter because it's not going to be really used. So when you change the waveform, where's the update rate again? Update rate. So rate voice equals that cycle. So rate frequency equals that. That should hold my frequency. And with the frequency in hand, I can calculate my filter. This way, the filter is always going to close a bit. And you can, when the voice goes lower. Let's put 400 Hertz above so it doesn't cut too much of the higher frequencies. Yeah, let's test it out. Now it's not working the way I want. Maybe I'm closing too much. Closing a bit too much. Maybe I could check for the frequency. Because I want it really close to the end of the keyword, but I have to check the actual waveforms how it's outputting. Oh, I'm just guessing the numbers again, but maybe I could leave this on update rate. Does sound very good now. But there is still one thing I want to do. Let me check something. And this one hard to check. Because I want to sample. If I can sample directly the way I want. Okay, take a look. Amplification, normalize. I still don't know very well how to handle this program, but Gaussian audio. Because maybe this is not really an issue, but I was thinking about when the sample goes very low in rate, I could interpolate. You can see here. Let me magnify this again. Normalize. A bit hard to see, but the samples are jumping like step ladders. Maybe this part here is easier to see, but I wonder if that is really going to produce anything that can be heard. Maybe I shouldn't bother too much. Maybe the low pass filter I'm adding should already be enough. But it's always nice to have control to how the filter affects the audio. So I'm going to add an option for that too. So at least the anti-aliasing filter can be used in other ways too. So I'm going to take a quick break now and be back in a while, okay? Okay, I'm back. So what I'm thinking here, I'm going to add filter key track. We add this option. And going to be after quality. Let's go add this filter track. And it's going to be by default 0. 0 is the minimum, the maximum is 1. And when it's 0, it's off. Close this up. Now on my wavetable I have to get this value. It's going to be filter track. I hurt my finger. Sample and on the processing, I have to add this before the processing. My finger. I did something in the finger and I was hurting a lot. Yeah. Filter track. Okay, now it's in there. I have access to it. What I want to do about it? Oh, here, rate frequency. So here, filter frequency. Filter frequency equals 200. And if the filter track is higher than 0, then I have to create some sort of math for that. Track. So how can I work with that? Well, maybe I'm going to make a crossfade from 22,000 to the frequency of the voice. So for that I go like 20,000 times 1.0 minus the track plus the rate frequency times on the filter track. That's going to be my filter frequency. It just crossfades from one value to the other. Good work. And I'm thinking on another thing too. We are going to change something. I'm going to create another update rate. Now the update rate I no longer have the force option and updated by voice. Okay, it's much better. Now I'm going to put the filter frequency inside the rate check. So, okay. What have I done now? My update rate now can be every 8 milliseconds. That should be good enough. I would know better when I test with pitch bend, so create a new project for the change the structure of my internal values. Create a new project. Ah, come on, why it's doing that? Okay, so let's check why it's doing that before I can do anything else. We have the standalone version where I can test with that. Yeah, I have the standalone version. Actually trigger, that's okay. Process. Okay, so it's something related to the plugin format. No problem, we can test it out. Oh, Control 3, Reaper. Ah, come on, and now it works. Ah, computers. Sometimes I get tired. Higher. So let me check what I did wrong with the keyboard tracking. Where is it? The frequency. So if filter track is higher than 0, let's say it's 1. 1 minus filter track 0 times 22,000 0. And then the rate frequency times the filter track. Rate frequency. Okay. Wow. Should be working okay. Let me check what's going on. Interesting. Just check if the filter. There's always something going on. There are a few things that's very strange. Start with it's correct only mode mono. It's on mode mono. White quality is not high. Oh yes, this mode. This quality should be 4. Everybody is not updating the way I want. Now, just for the fun, let's try this. Yes, you need to figure out why it's crashing. hate when that happens. Check. Oh, bloody thing is quality filter track, not pitch bend. I would expect something to work if you don't put it in the right place. Anyway, now it should work. You need to check why it's crashing during start. Oops, not good. Looks like something bad happened. Let's try again. Oh, I see it. Clear the audio. And it's stopped my audio totally. Track is off now. It's no good. Oh, division by 0, of course. Division by 0. We never learn. No, we don't. Come on, Reaper. Reaper. You know what was my favorite doll for testing? Orion. I can't divide by 0 now. Did I do that again? But I put it. J-Max in there. Oh, it's divided by 0 again. Maybe it's breaking the filter. Some filters don't like to go too low. Could be that. Let's try. 400. The crazy things in life. Okay, now the question is, why it's not working per voice? Oh yeah, I'm changing for all the notes, but you should be doing per voice. Rate frequency, the frequency, separate. It should be computer per voice. And another question is, if you don't need a filter track offset, because the filter is cutting right on the top of the node, and maybe adding an offset allows you to adjust depending on what you are doing. That will be nice. So let me try to do that. Now this time I'm going to pay attention what I'm doing. Filter track and filter offset. Track. Offset. That is actually going to be U, but it goes from -1 to 1. Ah, my eye. While filter offset is going to give a much better result, and then I can start work on the rest of the code. I'll finish this first. I have the filter offset. Oops. And I have to tell on the process. At some point I may change this start process to something more optimize it. Do offset, not upset. Never mind. And then filter minus the filter on the owner, the filter offset. Oops, filter offset. So now I have to convert this from 0 to -1 times 8000 Hertz. And I try to adjust the value here to 220 Hertz. 100 should be okay. Should not crash the filter. No, it's making strange sound. Now at least I should have some extra options to adjust the filter, because this is not the main filter. Maybe I'm going to rename this something else today. I'm just reusing the filter there. I just don't understand why it's not updating the frequency in the loop correctly. Let me check again. should be updating the loop. Oh, come on, what's going on? Reaper is stopping the audio. It is changing. Nine buzzing sound. So now it's time to benchmark this filter code that I introduced today. Before I do that, make a copy. Never leave home without making a copy. Backup. Make a backup. I'm going to upload this somewhere. Today is 26. And then I can open. I can open my benchmark tool. And okay, what we will look for this time? I'm going to keep my same filter code from the old version of Juice. And because it's a good filter code, it works. I have been using this for years. That's why I was so upset I was not working, but I was doing something wrong, as you saw. And what I'm going to check now. So first, what I'm going to do, where is it? Okay, see. I'm not going to use for point interpolation because it's a bit overkill, but we didn't really test it again, so after I fix things up. So I guess let's do that first. Again. Here I'm getting 4 samples. Instead of linear interpolation, let's do interpolation. Now, let's put the Reaper Fear processor, not Führer, Fear. Sorry, that's lame. What you have now, quality the highest possible. I'm using the code. Okay, that code. Change this envelope. It's getting on my nerve. Hey, I just changed it. Oh yeah, I changed the wrong value. Print screen. My photo plus. Yeah. And now I can save this project. Test. let's put back the linear guy. I'll have to test also if oversampling 8, I guess. That's okay. To be able to test here. Quality high. Let's take a look now between those two guys. This is the Hermit interpolation, and this is the linear interpolation. Hey, stop doing that. Well, the difference is on the high end, of course. This one is a bit more dirty. I don't know if that's a name, but that's the. Stop doing that. I don't know. This problem sometimes gets crazy. So linear interpolation is really bad. The Hermit gets a much nicer resulting graphic in here. So let's keep it. It's a keeper. Let's get rid of linear interpolation, just use a Hermit interpolation. And it can also produce better audio in the lower end, if I remember correctly. So now I have 3 things to optimize: the Hermit interpolation code and the filter design, the 3 poles. So maybe first thing I could do is split the filter code so it's easier inline. We need out and in. It's called filter process. We call 3 times for different poles. 0, 1, and 2. So with that would work. And I need the input as well. I hope my name is right. And oh, right, filter buffers. The poles in here. Buffers. Pole. Okay. This is working yet. Yeah, it works. Quality, with a track. That's very muffled. Still something strange in here. The way I'm processing the changes in the rate. I will figure something out. So before I continue, I want to check hide hex crashing when initializes. I need to know that. Doesn't crash. Well. Ah, maybe it's crashing because I changed the structure and didn't restart the code. This is weird. I'm changing the filter track and it's processed in the change of the rate. It's called, let me check when it's called, but well, it was changing the fine tuning, so it is being called. Rate frequency, getting from there, and it's applied for filter coefficients. That's just weird. Just to get on my nerves. Well, there must be an explanation. I found it. My coefficients I was setting as fixed to all voices, and it should be per voice. Just a small errata. Now here I have to use voice instead of that. V is for voice. So it's just a small macro that adds the number to the voice number. Nothing fancy. I'm showing here, learn way on the top. Oh, it's not there. Where is it then? I was just using it now. Oh, here, V value plus voice. And now it should work. Why it's crashing now? Go. Don't like that. Now I should be able to set filter track. And then nothing happens. Come on, what is it? Oh yes, of course. Put it the wrong way in here. Why? It's like this. That's why. That's what happens when you don't pay attention. I'm starting to get a bit tired already. I don't have any chocolate to eat. My wife ate it all. It's still wrong. What the? Let me check again. There's something fishy going on. Max number of voices. And when I record it, oh, no, that's correct actually. That is correct. All the coefficients are going to for the voice. Well, that seems correct. Why? Check where the update rate is happening. This guy here. Okay. I'm going to change waveform. There's no false. Oh, that's why. Really. Just a second. Finally, some food. Thank you, wife. I don't know how to call this in English. It's a sweet thing. It's very good. All good now. Let's test the AVX code now. Yeah, works as expected. Okay, let me make another copy of this. Yes. Why did I open Cubase? No. Go away. I don't want to. And let's start benchmarking this again. Benchmark for 1 second worth of samples. And then I have to add a few things in here because I changed something. So the wavetable start process changed. Now oversample is going to be the maximum oversample. And no filter attack, no filter offset. Jack beats. So by default it's 32 voices. And let me check what I changed. Which one? I forgot to remove the old one. Let's get the number. Those are the numbers. That's a bit high. Let's see how much of this is from the filter. That can't be right. Is this right? That's crazy. No, that can't be right. Or maybe it is. Whoa. That's not good. Okay, so the first thing I want to create an option that allows me to add and multiply but I had it already at one time, but I'll remove it. as static. Multiply, multiply add. Let me check now. I'm using SSE. Different. SSE doesn't have an option for that. So I just go in and multiply and then add and output the result. And I have to change the variables from AVX to SSE. Okay, so let's start working my way down in here. The output I'm going to multiply the voice first coefficient with the input and then add the buffer. And maybe in SSE is not going to help much, but should do in AVX. Where is? Huh? Ah, of course. I did it the wrong way. I can leave like this, but I have to do like this. I think 31 and 18. It's not much difference yet. Yeah, it's even higher. That's why optimizing the code is a big pain in the neck, because sometimes you do something that's good and then sometimes you do something that's not so good. I don't know, it's not computing faster. It's just weird. Unless, oh. Something here. So I'm declaring my output as the conjunction of that. Good. Work much faster. Then now I'm going to go like this. Oh, there is an option on the EVX to also subtract. It's FMA actually, not EVX. Let's add. Where is it? No, not this one. Multiply and subtract this guy. Multiply two values and then subtract. Wait, why it's showing like this? Is this one? Yeah, I mean, because it's 256 bits process. So it's multiply, subtract, multiply. And actually, the name could be just multiply. More easier to understand. And on SSC, we don't have that call. We just use a regular SSC code. Subtract. And instead of adding, we just subtracting here. Okay. Now here, change this guy. Now we go like this. Type multiplication and subtraction of the check something here. So this guy times this guy, and subtracted by this guy times this guy, and then added the other guy. Okay. So multiplication. This guy with this guy minus, and yes, you can't do this. Type velocity of voice times the output, and all this we write to the buffer. My legs scratching, it's itching. Okay, it's different. Let's see if it's lower. Okay, not by much, but enough to make me happy. But let's see if it's working. Now let me do this one final last one, and you can see it's working. Again, we're going to subtract instead of adding. So multiply by those two guys, and then all these remove it. Multiply the input and subtract the coefficient times output. Nice. That's what I call it optimization. It's still not running as slow as I want, but it's a bit slower in most situations. Let me try something different. And let's compare the numbers with more samples in mind. Maybe it shows a better result. But there's another thing I could do. You can see the AVEX is always faster in the long run. So, let me put all your code back and you can test. Oops. Yes. What else? T. Many T's. And okay, I see. And these formulas can get complicated. This one was where is it now? Oh, that's taking a long time. That was not that bad, but it is bad. So let's stick with this for now. Then I have to figure out a better way to write it. And then I have to check if it's working. Yeah, it is running better. I'm going to get these new values and start working with that. See what else can be done. So right now I'm working on the filter. Okay, let's clean this code up, but first let's test it. Why did that open? Not you. Nobody's home. What is happening? Okay, let me check. Code again. Output is multiplication of the input of the coefficients, and then add filter buffer. Then I have to write the filter buffer. Oh, this is not going to work. Pretty sure it doesn't work, so it has to go like this. But there's some limitations on how I did my C instructions. Not a big deal. Was on that. Could also be my C instruction. Let me take a look. Oh, this is in reverse. Or not. No, that's correct. That sounds correct. Application, then modification, then distraction, which you also oops. Just to avoid any mistakes. And the same thing here. But let me test this one out. Because I have to write the two buffers, otherwise the filter doesn't work. That's not good. Just to be sure there's nothing else broken. Back to the code and try again. Something I'm doing here. Let's go by parts. Coefficients multiplied by the inputs. Yeah, added by the pole. That's the output. Let me work directly by here. Okay. Check this one. This guy here. So coefficients 1 times the input minus the coefficients 3 times output. Oh, there's missing one guy here. Actually times the filter buffer. Nice. We can add all these, multiply by these, and then add this guy. It's a bit convoluted, but it should work. Too easier to understand than most things I have done. Because with optimizations, you gotta lose something to gain something usually, and that sucks. Down, down. Come on. Add. Come on, really. Work it. But now. 2 points, not 1 point. Yeah, almost there. Let's see. Multiplication. Let me put all these in like this so it's easier to see. Kinda easy. This is closed. And this is closed. One ugly little line of code, but should run much better. In this guy here, we don't need to worry about the buffer. We don't add the buffer like you did in the one before. Okay. So the other one is just the coefficient by the input minus the coefficient by the output. Yeah, that should be good. Oh yeah, working. And now, let's see if it's running faster or not. This is what I call good. The SSC is a bit higher, let's see why. But the AVX is a bit lower, which is good. strange. Strange that SSC got higher. Okay, I guess. Take a look at these. I don't know. I'm not going to worry too much about it. Now we can move to the oversample voice. Filter process I've done in there. But just to check, let's break the filter process code into one single call. And see if that helps at all. Forget the get directly avoid an extra variable. Get these. But mostly like the computer is not going to bother about that, so let's leave for now the input. Then we test if it's going to create another in-memory variable or not. It should use a register when it's fast processing. And I'm going to comment my filter code and create a new one. I'm going to take the input and the voice. And let's not have it return anything. I don't need that because I have access to the voice, so I can just go like X out right voice, and it's going to work. So now what I have to do is for each pole, let's watch what I have actually done in C before. Alt equals, one more. And input is not a constant anymore, and be a variable. So now the poles, I'm going to create some other variables for that, so it's easy to understand what's going on. Come on, really, pay attention. Pole 1, pole 2, and pole 3. And then create an enumerator for the pole 3, 0, 1, and 3. Good work. What's up? So, right, voice. Output. Is 6.2, 3.9. Interesting. It got worse. Why it got worse? And let's try another thing. Let's completely remove the template of the filter and just add everything in here. So x equals x dot right input. Okay, let's see. I don't get all the types of stuff that. Oh yes, that's why I'm trying to measure. I hope I'm measuring correctly. I just hope. See, it's worst. Why? For one, it's be 0 plus 1. Okay, that's all correct. I'm just mesmerized by the fact that it's running slower. Go figure. Code. Try again. Old code versus the new code. Oh, I don't know. So, the template. Let's try again. Weird. Something changed that now I'm getting this value. It's hard to trust my little tool for testing. Before was, yeah, it's pretty much the same now. That's really odd, but that's okay. Maybe the compiler is doing something that I don't understand and is actually improving the code somehow. Oops. I just think it's odd. That's all. It's not a problem. Okay, now let's try. Try that. I see one problem in here. Maybe like this. Maybe that's why it's running faster. What? .2.9? That's ultra weird. That's okay. Yes. Okay, last one. Oh, it's going to process. Let's test this one out. I'm going to test if it's still producing any sound. Doesn't seem to do much difference, this one. So I'm going to, oops. I'm going to leave it like this, because it's easier to read. And I still need to fix all this. But before I continue, let me see. This still works. I just like to work that way. Some people say, oh, Will is a bit crazy. Well, I am crazy. And it's not hard to work sometimes. But I try. Really try. This is me trying hard. People don't know what I say. And just for the sake of testing, let's try again. Instead of this, we do this. Oops, in the wrong place. Here. Ah, 2.9. Weird. It does produce nothing at all. Okay, let's remove this. This. Oh, these parts must get better. So C0, how many times it's used? Only once. So we don't need to go like that. And go this. Now check C1 is also user once. Because you can substitute this for just put a big name here just so I don't get confused. So define that. I'm going to use the multiply subtraction again. 5 multiply by samples subtracted by sample 0. Is that? Now there's a lot of multiplication here happening that I could use the extra power of the EVX for that. Especially in here, you can see that these alone already gives me an option to do that. So now we're going to multiply and add. So multiply and add C3 by interpolation and C2, and then we multiply and add again these sample interpolation and come on, go there. No, not there. And then there's more here. And then go again. Multiply and add all these. And sample interpolation. And samples 1. It's going to be the input. A long list. That's already should run faster, especially if AVX. Yep. Already a bit better. Not too much, but it is an improvement. Strange that SSC again got worse. Strange that. Maybe my code for multiply and add on the SSC side is not very well made. No? And multiply, well, very simple actually. I don't know what's not working better. See if it's still working, just in case. It's working. It's working already. Now these guys is a bit more complicated. I won't be able to do much about this. What I can do is define those guys as like that. And see how that runs. 3.8. Weird. Not right. .8, but worst. Interesting. That's one thing I have to say about the compiler. It usually does a very good job. So sometimes you think that something's not going to run fast because the compiler is doing something wrong. Well, maybe you're doing something wrong. Because if the compiler gets things in a certain way, it can optimize a lot. But if it starts messing too much with the code, sometimes the compiler gets confused and don't optimize as much. That's from experience, not from knowledge, because I've seen that happen. That's why I'm trying to test this as much as possible and see what I can do to improve and leave the rest for the compiler to do. But when it comes to parallelization, it doesn't do much with SSE and AVAX, stuff like that. So, okay, let me see now. I have to check now my parentheses here where they are. So those two guys are separated. Those two guys are separated as well. So let me check the AVAX instructions again and check if there is an option. That's not AVAX, actually, it's FMA. But no, there's no option for adding first and then multiplying. All the options are multiplying, then doing something, which doesn't help me at all. And in this case, it's not going to help me. Here it can help. So multiplication and subtraction. 5, 2, samples, whatever. And the problems with the reversing order of things that I can't do much about it. Unless I could go like this. This multiplied by that plus that, and then we add the rest. If that works, I can get a bit of extra optimization there. So, right. Minus E multiplication of 2 by samples and add that. If it's going to allow me to do that, it's going to actually help me a lot. Let me check if that was addition. Yeah, it's addition. Let's run this. Again, I'm getting some strange results. Especially in the FMA code. Interesting. Like my sim structure, maybe there's something wrong in here. But basically, I'm just returning well, I have an idea of what could be that. Well, anyway, it's already much better. It's a hell to read, but I don't care. It is readable, so it is possible to understand what's going on much better than just plain instructions. Yeah, but the code is broken. So let's go back a step behind and go back to that area alone and work from there. I'm not ashamed of going back. What was the last code that changed? Tick. That's all good. This, to be honest, this sounds a bit strange. Huh. Let me copy this. Oh, why is the problem? Oops, not copy that. Copy the whole thing. Sounds like a low pass filter now. Strangely enough. I just love those things. I just love the undo options on the programs. They always save my ass. Let's try this. That's the correct sound. Weird. Oh, take this guy here. And replace with this guy. Maybe I did something wrong in the filter. The loving process of wrapping the code out. Okay. Do this again. Use the coefficient times input. Put this on top again. And let's revise the code. Multiplication of the coefficient 1 by input minus coefficient of 3 times the output added for the filter buffer 1 and then save it on filter buffer 0. Okay. Then the coefficient 2 I see a problem already. I added in the wrong way. It's actually so the coefficient option minus minus out times out. Then we add the filter pole and then we write. Now that's correct. The other one is good too. Okay, now it makes sense. Oh, but I forgot to close the thing again. Okay, that's correct. And let's see the benchmark of this, because maybe now it improved somehow. But I think I was adding some extra work in there with the wrong formula. That's pretty much the same. 0.339. Almost high. Run again. Oh, 6.3 now. Go figure. Okay, let me clean up the mess in here. Let me recheck a few things out. And just take one thing out of order and then suddenly things don't work anymore. That's why math is so sensitive. It's starting to get hot in here because everything is closed. But I'm nearly finished for today. I just want to check a few things out in here. You're not going to mess much because there is not much I can do. I think that's it for the wavetable so far. It's running pretty good. The next step I'm going to do, I was not really going to allow to change the wavetable, but I think it's good to have an option to change wavetable. So I'm going to allow that. An option to load wavetable files, set of sounds that you can load from wave files, but not samples like big samples in SF0 or whatever. Just wavetables in a proper format that is going to be 600 samples or 1200 samples. So if your wavetable is in this region, you can load. It's a very common format. But what else? I was thinking there must be something here that I'm overlooking, but doesn't look to be like that. Usually I don't go like inserting the numbers directly like I'm doing here, but would create the static variables for that. But it doesn't always help. But just for the sake of testing, let's try that. We're going to use four values. I can go like this. Values. Something like that. And see if it helps at all. Oh, it's Christmas now. And another enumerator. Okay, 0, 0. Okay, 1, 5. And those are the numbers. And those are going to be 1, 1, 2, 3, 4. Have I created? Yeah, 4. And now I have to create this where the fixed values can be from the owner. It's better to be there. So here, fixed values 5. And this. It's a bit of a pain to do all that just to test something, but there is no other way. The order doesn't matter because I'm using the constants for checking the value, so not a big deal. Didn't make a mistake. Always something. Where is it? Why is suffix name? Where? There was suffix. It doesn't allow that. It's complaining. Very little source not found. Good. 05, 05, and 05. And okay. The same thing. So it doesn't help much. And the compiler already does the job of creating that. So let's go back in time. Me and my ideas. But that's okay. Okay, so I'm aiming for today, but I'm very happy with the result. The code is very compact. It's still possible to understand what's going on, and I really like it. Really, really good. Just this interpolation here, I'm trying to remember. I have to check something before I close for today. Yes, if I did do the things in the right order here. Oops. Just to be sure, because this looks a bit strange. Oh, it's actually correct. So it's C3 times sample 3 adding 2, then multiplied by sample internal adding 1, and it's sample multiplied by sample property and then 0. Yeah, that is correct. Crazy, huh? So okay, guys, that's it for today. And sorry if my videos are not the most fun ones to watch, but at least I'm trying to show how hard it is to create something from zero and how crazy it is for me to code. There are days that it's very hard, but it's okay. I'm trying to work. So thanks again for watching, and I hope you have appreciated something about this video. And that's it. Thanks.